So what have we covered in this block? We've been looking at functions, particularly how functions are represented in Haskell as curried functions. Every function in Haskell, though it may look as though it takes multiple arguments, in fact takes a single argument, and applied to that single argument, it might return a function which could be applied to another argument, and so on. So we have this curried representation that supports partial application. So that means functions like multiply, which takes two arguments to return the product of those arguments, when applied to one argument, will give us a function that multiplies by that argument. So those things go hand in hand, and those give us a way of returning functions as results of calling other functions. We also saw lambdas were a way of explicitly writing down function expressions, for example, as a result of a function, but also in general, that's a way we can denote functions. And we can use lambda defined functions, for example, as arguments to things like map, which take a function as an argument itself. So we've been seeing functions as data, functions going into functions, functions coming back from functions. And what functions give us is behavior as data, and that allows us to write nice APIs like the API for map, where the behavior, the transformation that we perform on a list is just a parameter of the function itself. We can also think about behavior being data in representing particular kinds of objects, and we did a case study where we represented regular expressions by functions. That's a nice direct representation of those functions, but we can also represent regular expressions by data, by a data type, which then can be interpreted as the function that recognizes strings matching a particular regular expression. And we concluded by defining another abstraction, or two abstractions, fold_var and fold_l, which embody recursion and tail recursion over lists. So these are functions which capture the pattern of primitive recursion or tail recursion in a single function, which has functions as arguments, and also when partially parameterized, partially applied, will give us a recursive function. Okay, so I think there's been quite a lot of perhaps novel material here. And this is stuff that I've been emphasizing that you'll see in other languages apart from Haskell, but this is the place where you see it perhaps most clearly and most elegantly.